Have you ever wondered how a smoke detector works? What's the difference between a photoelectric detector and an ionization type detector? Why is my smoke detector so critical of my cooking? I'll answer all of this and more on today's episode of Alarm Academy. Hello and welcome to Alarm Academy. Today we'll be discussing how photoelectric smoke detectors work. So what is a photoelectric smoke detector anyway? Well, in most protected buildings you'll find either photoelectric or ionization type smoke detectors. You may have been told that there is radioactive material in your smoke detector, and that is potentially true if you have an ionization type detector. Ionization type detectors are most commonly found in residential applications, but there is another contender that's been gaining traction in the residential community for fire alarm, and it's photoelectric detectors. This is an example of a photoelectric smoke detector. If you're interested in learning about ionization type detectors, I'll be creating another video on that. When I do, I'll link it in the description. There are three main parts that make a photoelectric detector work. One is the LED, two is the photodiode, and three is the smoke chamber. An LED is an electrical component that creates light. A photodiode is an electrical component that takes light and converts it into electrical current. The smoke chamber is where the smoke passes into to be processed by the LED and the photodiode. A photoelectric smoke detector typically has a smoke chamber that is round, surrounded by a mesh filter, and contains plastic pieces that aid in the operation of the LED and the photodiode. Did you know that smoke is reflective? Photoelectric detectors rely on this reflectivity to operate. This is a system sensor model 2WB, meaning that it is a two-wire photoelectric smoke detector, something you might see on a burglar alarm or a conventional fire alarm system. I'm going to disassemble it to show you how it works. First, we're going to take the cap off. And you can use this method to clean your own detector if you have it. Just be very careful. Then we have the filter that covers the smoke chamber. Now just pop that off, gently prying it straight out. It's got mesh on it to prevent certain particulate from entering the smoke chamber that is not smoke. And then inside we have an LED and a photodiode. It's hard to get a good image here of what those look like, but they're very similar in appearance and it can be hard to tell which one is which. So you'll notice that these channels are angled. This is so that the photodiode and the LED are not pointed directly at each other. There is only ambient light that can be detected by the photodiode to see if it's in a normal or a dirty condition. When smoke enters the smoke chamber, light from the LED bounces off of the smoke because it's reflective and into the photodiode, which is what triggers an alarm condition. So why doesn't my smoke alarm appreciate my culinary prowess? Well, both smoke and steam are reflective, so if you're producing either one of those while cooking, the detector can go into an alarm condition. You shouldn't have a smoke detector close enough to your kitchen to regularly cause false alarms. If this happens too frequently and you're not burning everything you cook, consider installing a heat detector instead of the smoke detector in the same spot. If you need help with that task, call an electrician or an alarm contractor for further assistance. So what happens if a detector collects dust or becomes dirty enough to prevent the photodiode from operating normally? With a fire alarm system, the fire panel decides when to go into alarm based on the level of smoke that is obscuring the air in the smoke chamber. This is called the level of obscurity. Even though the light from the LED is mostly obstructed from the photodiode, a small amount of ambient light from the LED is detected in normal operating conditions. When non-reflective dirt or dust particles obstruct the LED or the photodiode, the panel reports an abnormal level of air obscurity and will create a trouble signal, typically called dirty or dirty smoke, to alert the building owner to clean or replace the detector. This condition is uncommon in a residential setting, but your smoke alarm may show signs such as a false alarm or unusual sounds from the detector. It's important that you clean your detectors monthly with either a vacuum hose or a can of compressed air that you'd likely use to clean your keyboard out with. So what if the LED or the photodiode fails? Just as a dirty condition can be detected by a fire alarm panel, a failure condition can also be detected based on the level of obscurity and internal circuit data. If the detector or panel fails to diagnose the issue, we have a failsafe. Commercial fire alarm systems are tested at least once annually, and residential detectors should be inspected and tested at least monthly to prevent any false alarms or inadequate protection. Let's review. Two of the most common types of smoke detectors are photoelectric and ionization type detectors. The three main components that allow a photoelectric detector to work are the LED, the photodiode, and the smoke chamber. Smoke enters the chamber, light from the LED bounces off of the smoke and is reflected into the photodiode. The photodiode converts the light into electrical current, which triggers an alarm condition either at the fire alarm panel or on board the detector, causing the fire alarm system or the smoke alarm to signal evacuation. Remember, if you're in a building and an alarm system is activated, go outside immediately or follow the instructions that are provided by the alarm system if it's voice evacuation.
But no matter what, no matter how scared you feel, never, ever hide. Don't hide. Go outside. Can you remember that?
If you can't determine the cause of the alarm, never assume that it's a false alarm. Allow the fire department to determine if the building is safe before re-entering it. The fire alarm system may have detected a fire that you haven't noticed yet. In a residential setting, as long as you are conscious, it's likely that you'll detect smoke just as quickly as the detector itself. If you can't immediately extinguish the fire, if you're a child, or if you're otherwise unprepared to extinguish the fire yourself, go outside right away and call 911 or whatever number your area uses for emergency services. Make sure you're cleaning and testing your detectors every single month. Try to do it on a day where something else mandatory is scheduled, like your rent or your mortgage, so that you can remember. Replace your detectors every 10 years or per the manufacturer's guidelines. Write the installation date on the detector to help you keep track of this. Smoke alarms are critical in houses, primarily to wake you while you're sleeping. Unfortunately, smoke inhalation will kill you before it will ever wake you up. You must maintain your detectors to ensure that you will wake up quickly and exit the house before flashover can occur. Flashover is when fire spreads rapidly across a gap because of profound heat and can occur within 3 minutes, so it's very crucial to evacuate and allow the fire department to make sure the house is safe before you re-enter. No one wants to be in a house where the air is on fire.
Be cool about fire safety. Be cool. If you want to stay alive, be cool about fire safety. Or listen and you'll survive.
Approximately 2/3 of fatalities that occur in residential house fires occur in homes where the smoke detector is disabled, poorly maintained, or removed. It takes very little effort to maintain your life safety systems, and it will make all the difference if the unthinkable happens. Those are some harrowing statistics, so here are some kittens to lighten the mood. If you found this video interesting or helpful, please consider liking, sharing, and subscribing, and maybe even commenting. If you have any kind of questions or if you have any requests for future videos, I am absolutely taking suggestions for further topics to discuss on this channel. So if you could help me out with that, that would be great. I waited 2 months for this dress to come in that I had custom made, so I thought I would show it off last minute. Check it out! I drew those by hand in AutoCAD, and these are the NFPA symbols for smoke detectors. I apologize if I sounded a bit stuffy during this video. I've been fighting a sinus infection for about 2 weeks now, and I'm pretty much ready for it to go away. But it's hanging out, so I thought I'd go ahead and film my video anyway. Anyway, thanks for hanging out with me today to talk about photoelectric smoke detectors. Stay alarming, my friends.